Here we're asked to expand the quantity a squared minus 3 raised to the fourth power using the binomial theorem. Now the binomial theorem states that any binomial raised to the nth power is equal to the sum as k goes from 0 to n of n choose k times x to the n minus k power times y to the k power. And so in this case, a squared will be equal to x in the theorem. And negative 3 will be equal to y in the theorem. And of course, n is 4. And so using the binomial theorem, the first term will be equal to 4 choose 0, and that's where n is 4 and k is 0, times x to the fourth power, in this case, a squared to the fourth power, times y to the 0 power, in this case, negative 3 to the 0 power. Now the second term will be equal to 4 choose 1, where k is equal to 1, times a squared to the third power times negative 3 to the 1 power, plus. Now the third term is 4 choose 2 times a squared squared times negative 3 squared, plus 4 choose 3 times a squared to the 1 power times negative 3 to the third power. And then finally, for the last term in the expansion here, we have 4 choose 4, where k is 4, times a squared to the 0 power times negative 3 to the fourth power. Okay, once we expand using the binomial theorem, we then simplify. Now 4 choose 0 is 1, times a squared to the fourth power would be a to the 8th power, and then of course negative 3 to the 1 power is 1, plus 4 choose 1 is equal to 4, a squared to the third, it's a to the 6th, and then times negative 3, plus 4 choose 2 is equal to 6, a squared squared is a to the 4th, and then negative 3 squared is 9, plus 4 choose 3 is equal to 4, a squared to the 1 power is a squared, times negative 27, plus 4 choose 4 is 1, times a squared to the 0 power is 1, times negative 3 to the 4th is positive 81. And so cleaning this up, we have a to the 8th minus 12 a to the 6th plus 6 times 9 is 54 a to the 4th minus 108 a squared, and then plus 81. And here we have the expansion of a squared minus 3 raised to the fourth power.